All right, let's talk about dividing fractions. We've multiplied fractions, now we're dividing fractions. And dividing fractions is just an extension of multiplying fractions, and here's how. So we're going to follow these steps. We're going to write all mixed numbers as improper fractions, as we have already done before. Then we're going to change the division symbol to multiplication and flip the second fraction to its reciprocal. And we're not going to say kiss. No. We're going to say keep, change, flip. Keep the first fraction, change to multiplication, and then flip second fraction. Okay, that's what we're going to have, keep, change, flip, and I'll come right over here on this side as well. That's what I'll just do. So, keep the first fraction. Change from division to multiplication, and then flip the second fraction, which is the reciprocal. Okay? So, get my pencil. Let's go over here. So then after you keep, change, flip, we're going to multiply the numerators to get the new numerator, and then multiply the denominators to get the new denominator, and then simplify if needed. Okay, you may not always. We talked about when we were multiplying fractions, a way to avoid having to simplify when we cross-simplify before we actually multiply, and that also saved us some time as well. Again, you can choose to do it whichever way you feel more comfortable doing. So, we're going to find each quotient and then give all quotients in simplest form. So, I'm going to keep my first fraction, change my division to multiplication, and then flip my second fraction. Okay? I'm going to try to cross-simplify. I'm starting with these two guys. So 1 and 5, well, 5 is a prime number, and the only other factor of 5 is 1. So this is as simplified as it gets. But the greatest common factor, though, of 4 and 6 is actually 2. So 4 divided by 2 is 2. 6 divided by 2 is 3. And now we can multiply across. 1 times 3. Yeah, we did. Made me nervous. I thought we had done the reciprocal. So now we have, or you know what we'll do? We'll rewrite it so it's cleaner. 1/2 times 3/5. Okay. And then we get 1 times 3 is 3. 2 times 5 is 10. Now, if we simplify, if we cross-simplify correctly, then this fraction here should be simplified, meaning the greatest common factor of 3 and 10 is going to be 1. But we already know 3 is prime, and 10 only has 4 factors, 1, 2, 5, and 10. Okay? So I'm going to highlight this so I know it's correct. And so do you. Okay. So let's look at this one, number 2. 4/5 divided by 6/7. So we're going to keep the first one, change from division to multiplication, and then flip 7/6. So let's look at these two guys, 7 and 5. Well, they're both prime. Remember, we have to know our factors. They're both prime, so we can't simplify. But the greatest common factor of 4 and 6 is 2. So 4 divided by 2 is 2. 6 divided by 2 is 3. So when I rewrite this, 2/5 times 7/3 gives me 2 times 7 is 14. 5 times 3 is 15. I get 14 fifteenths. All right. And then I have 2/3 divided by 1 2/3. Well, make sure our mixed numbers have to become improper fractions. So let's start with this. I have 2/3 divided by. We're not going to keep change flip until we know that we have improper fractions. Denominator times whole number is 3 plus 2 more is 5. 5 over 3. Now I can keep change flip. Keep 2/3, change division to multiplication, and then flip 3 over 5. Okay? So, if I were to cross simplify, well, it's the same exact number. Okay? So it would basically cancel itself out. And I'm left with 2 over 5. Okay. So let's look at number 4. I have 2 mixed numbers. So I'm going to draw an arrow down. 4 times 1 is 4, plus 1 more is 5. 5 over 4 divided by, because we're not going to keep change flip until we have fractions, not mixed numbers, but fractions. 8 times 1 is 8, plus 1 more is 9, 9 over 8. So now I have 5. I'm going to keep change flip, so keep my first fraction, change from division to multiplication, and then flip my 8 and my 9. So if I'm looking at these two guys for cross simplification, well, 5 is a prime number, and it doesn't go into 9, so we can't do anything about that. But I do know that the greatest common factor of 4 and 8 is actually 4. So 4 divided by 4 is 1. 8 divided by 4 is 2. And I'm just going to come over here and rewrite. 5 over 1 times 2 over 9. Oh, look what's going to happen. Now I have 5 times 2 is 10. 1 times 9 is 9. We cannot leave this as an improper fraction. We have to divide. So 10 divided by 9. 9 goes into 10 one time. 1 times 9 is 9. Subtract 1. So think about those notes where we did improper and fractions and mixed numbers. So my whole number is going to be my quotient 1. Remember, my denominator always stays the same. And my remainder is going to be my new numerator. So I have 1 1/9. Okay. Then number 5. I have 3/4 divided by 1 1/4. So I need to make sure that this is an improper fraction. So I have 3/4 divided by, because we're not going to keep change flip till we have fractions. 5 times 1 is 5, plus 4 more is 9 over 5. Now we're going to keep change to multiplication and then flip 5 over 9. So if I cross simplify, I know 5 is prime and 5 is not a factor of 4, and 4 doesn't go into 5, so that stays as it is. But my greatest common factor of 3 and 9 is 3, so 3 divided by 3 is 1. 9 divided by 3 is 3. And so now I get 1 times 5 is 5. 4 times 3 is 12. And then to check if this fraction is in simplest form, I ask myself, what is the greatest common factor of 5 and 12? And in this case, it's 1. So that's it. I have 1 2/9 divided by 5/6. Okay, so I have to turn this into an improper fraction. So 9 times 1 is 9, plus 2 more is 11. So I have 11 over 9 divided by 5/6. Now I'm going to keep change flip. Keep my first one, change to multiplication, flip to 6 over 5, okay? If I cross simplify, 11 and 5 are actually both prime numbers. So the greatest common factor they share is 1, so I cannot do anything about that. But the greatest common factor of 9 and 6 is 3, so 6 divided by 3 is 2. 9 divided by 3 is 3, so I get 11 thirds times 2 over 5, and I'm going to get, 22 over 15. Ew. Yes, we have to divide. So now I have 22 over 15 divided by 15. 15 goes in 22 once. And when I subtract, I get 7. So I get my whole number at 1. It's my quotient. Denominator stays the same. Remainder is my new numerator. Okay. 2 more on this one. And I'm doing them all because this is a fairly new skill for most of you, and I want to make sure you get it. All right, 3 divided by 2 and 2/5. Well, I have to have fractions, and right now all I have is a whole number here, and I have a mixed number here, and it ain't going to fly. So to make a whole number, a fraction, you just write your whole number and your fraction bar, and 1 is your denominator because anything divided by 1 is itself. So I'm divided by, so denominator times whole number is 10 plus 2 more is 12. My denominator stays the same. So now I can keep, change, flip. Keep, change to multiplication, reciprocal 5 over 12. Okay? And then I cannot cross simplify 5 and 1. 1 is not prime nor composite, but it goes into 5. But 5 doesn't have any other ones as prime. We know. But the greatest common factor of 3 and 12 is 3. So 3 divided by 3 is 1. 12 divided by 3 is 4. Let's rewrite that. 1 over 1 times 5 over 4 gives me 5 over 4. But ew. So 5 divided by 4. 4 goes into 5 one time. Subtract. My quotient is my whole number. Denominator stays the same. Remainder is my new numerator. I know, it's a lot. I know, it's a lot. Now, 5 and 1/3 divided by 1 and 1/9. So I'm going to, denominator times whole number is 15 plus 1 more is 16 over 3 divided by 9 times 1 is 9 plus 1 more is 10 over 9. Keep, change, flip. Okay, so I can cross simplify both. This is great. The greatest common factor of 3 and 9 is 3. Okay, and let's see, the greatest common factor of 16 and 10 would be 2. So 10 divided by 2 is 5. 16 divided by 2 is 8. Okay, so now I have 8 over 1 times 3 over 5, and I get, oopsies, 8 times 3 is 24. 1 times 5 is 5. So now we gotta divide. 24 divided by 5. 5 goes into 24 4 times. We get 20. The remainder is 4. So here we go. Quotient is my whole number. Denominator stays the same. Remainder is my new numerator. And there it is, folks. See how this one goes. Look at this. Look at this awesome stuff. Okay, number 9. I have 2 and 5/8 divided by 6 and 3/4. So again, 8 times 2 is 16 plus 5 is 21 over 8 divided by 4 times 6 is 24 plus 3 is 27 over 4. Keep, change, flip. Okay? See, the greatest common factor of 8 and 4 is 4. So 4 divided by 4 is 1. 8 divided by 4 is 2. Let's see, 21 and 27. I'm going to go with 3. 21 divided by 3 is 7. 27 divided by 3 is 9. 7 halves times 1 9. And I get 7 times 1 is 7. 2 times 9 is 18. So we'll come down here. 7 over 18. Okay. 9 and 1/3 divided by 4. So let's make these improper fractions. 3 times 9 is 27. Plus 1 more is 28 over 3 divided by, because we're not done yet, 4 whole number as a fraction is 4 over 1. Now let's keep, change, flip. Keep, change, flip 1 over 4. And let's see, can I cross simplify 3 and 1? No, but I can cross simplify 28 and 4. 4 divided by 4 is 1. 28 divided by 4 is 7, and I get 7 over 3 times 1 over 1, which is 7 over 3. Now I got to divide. 7 divided by 3. 3 goes into 7 twice. 2 times 3 is 6. So my quotient is my new whole number. Denominator stays the same. Remainder is my new numerator. And I have 3 and 3 sevenths divided by 10 21st. So 7 times 3 is 21, plus 3 is 24 over 7 divided by 10 over 21. Keep, change, flip. Keep, change, flip. Okay? So the greatest common factor of 7 and 21 is 7. 7 divided by 7 is 1. 21 divided by 7 is 3. The greatest common factor of 24 and 10 is 2. 10 divided by 2 is, is 5. 24 divided by 2 is 12. So let's rewrite this so it's not so sloppy. 12 over 1 times 3 over 5. 12 times 3 is 36 over 5. Now we have to divide. 5 goes into 36 7 times. 7 times 5 is 35. So, whole number is my quotient. Denominator stays the same. Remainder is my new numerator. Let's look at number 12. So we are adding and then dividing. And you were going to learn later on in order of operations. Nope, I lied. Don't listen to that. Nope, this is something else. So we have to add these two fractions before we can divide. So when we add, we have to have common denominators. Okay? So we're looking for the least common multiple of 4 and 20, which is 20. So this is going to stay. 9/20ths won't change. But then how do I get from 4 to 20? That's right, I multiply by 5. Whatever you do to the denominator, you do to the numerator. 3 times 5 is 15. Okay, so 15 plus 9. Hear me out. So now I'm going to come over here. 15/20ths plus 9/20ths gives you 24/20ths. Do not change that fraction. Leave it improper. Okay, just leave it alone. So now I'm going to come down here. I have 24 over 20 divided by 6 over 25. But we're going to keep, change, flip. Keep that first fraction. Change to multiplication, flip. 25 over 6. Cross simplify. The greatest common factor of 6 and 24 is 6. 24 divided by 6 is 4. Greatest common factor of 25 is 5. So 20 divided by 5 is 4. 25 divided by 5 is 5. Let's rewrite this. It's ugly. 4 out of 4/4 times 5/1 gives me 20/4. And when you divide, well, 20 divided by 4 is 5. That was a lot. That was heavy. Let's look at these fabulous word problems because, life isn't complete without them. A container of juice contains 10 7/8 cups. If the serving size listed on the package is 3/4 cups, how many servings are there? So when we're dividing, we got to ask ourselves, like we did with dividing decimals, what are we dividing up? The container of juice or the cups? Yeah, the juice. So I'm going to say 10 7/8 divided by 3/4. Okay? So 8 times 10 is 80, plus 7 more is 87/8 divided by 3/4. Now we're going to keep, change, flip. You can simplify. So the greatest common factor of 4 and 8 is 4. 4 divided by 4 is 1. 8 divided by 4 is 2. You know what? I'm going to come over here and see. Does 3 go into 87? Oh, it does. Ooh, yay. So 3 divided by 3 is 1. 87 divided by 3 is 29. Guys, always try it, because if you don't, it's going to be ugly when you're dividing. So 29 divided by 2. Okay? So we got to divide. 29 divided by 2. 1. 8. Is that right? Is that right? 2 goes into it. 2 times 4. Yep. So, how many servings are there? Whole number 14. And I know you're probably thinking, well, shouldn't it be a whole answer? Not necessarily. And if you go home and look at the product packages, see my remainder, denominator stays the same. Sometimes it'll tell you about 3½ servings of something. And you would think, well, that's silly. So 14 1/2 servings. And then how many bracelets can be made using 10 5/6 feet of string if each bracelet requires 5/8 feet of string? So what am I dividing up? Yeah, the string. So 10 5/6 divided by 5/8. Okay? So got to turn it to an improper fraction. 6 times 10 is 60 plus 5, 65/6. And then we're going to change, and then we're going to flip. Okay? 5 goes into 65. Is it 15 times? Or is it 5 times? 15, 30. I'm having a moment, friends. Let's see, 65. Look at me not wanting to do the math when you have to. 13 times. Okay. So this becomes 1. This becomes 13. The greatest common factor of 6 and 8 is 2. 6 divided by 2 is 3. 8 divided by 2 is 4. I'm going to rewrite this ugly. 13/3 times 4/1. And we get 26 plus 26 is 52/3. But we still need to do the math. So 52 divided by 3. Really? Really? Yeah, okay. 7. So here's the thing. How many bracelets can be made? Well, look at this. I got 17 1/3. You don't make a part of a bracelet. So if I had to say, like, this is the number I can make, then it would be 17. So I would say only 17. You don't make a third of a bracelet. You'll have some leftover string, and that's okay. Mrs. Kessler is filling test tubes with a solution to use with his silent, with his science students. If he has 220 milliliters of solution and each test tube can hold a maximum of 9 1/3 milliliters, how many test tubes will he need? Well, here's the thing. 220, make it a fraction, over 1 divided by 9 1/3. 220 divided by 3 times 9 is 27, plus 1 is 28, over 3. Okay? Keep, change, flip. Can 28, oh no it can't it? Let's go at least 2, right? How many? Let me see real quick. Did you hear that bell? No. No. Haha. Divide by 4. So that gives us 55. That gives us 7. So now I have 55 over 1 times 3 over 7. That's more doable. So now I have 165 over 7. Okay, guys? So now over here I have 165 divided by 7. 7 times 2. 3. Okay, here's the thing. I have 23 and 4/7. The question is, how many test tubes will he need? So here's the thing. You're still going to have fluid left over. So in this case, you're going to have to round up. You will need 24 test tubes. Okay? There we go. That was a lot, I know.